The last activity we're going to look at today is class activity 4L on page 96 of your activity manual. And so this is where students are going to try to use the distributive, associative, commutative properties, right, all the properties we've discussed so far, to calculate some multiplication problems. And so here Kylie has an idea to how to calculate 23 times 23. Well, Kylie says 20 times 20 is 400. So Kylie says 20 times 20 is 400, which I agree, right? That's two groups of 200, 400. And 3 times 3 is 9. So Kylie thinks that 23 times 23 should equal the sum of these two, 409. Now, that's not quite right. If you check that on your calculator, you're going to see that is not the answer. So how can we figure out why it's not correct? So this array has 23 rows and 23 columns. And I'm going to split it apart at 20 and at 20, right? Because that's what Kylie does. She says, well, that's just 20 times 20, which means that this piece has 400 squares, and 3, that's these 9 squares. But notice Kylie's strategy is missing all of these squares over here and all of these squares down here. And so how many squares is Kylie missing? Well, she's missing 20 times 3, which is 60 squares here, and 20 times 3, which is 60 squares over here. So really, 23 times 23 should be 20 times 20 plus 2 of those 3 times 60s plus the 3 times 3, right? And so that's 400 plus, I have 180 here, another 180 here, and a 9. So 400 plus 180 is 580, plus 180 is 680, and then 760, 769. So you might actually recognize this picture, because this is the picture we often use so when we're talking about something called FOIL. And I don't love this acronym because it's really just the distributive property over addition, right, of multiplication over addition. But notice that's what's happening when I take 23 times 23 and view that as 20 plus 3 times 20 plus 3. Because I multiply my firsts, 20 times 20, my outers, 20 times 3, plus 20 times 3 for my inners, and then my 3 times 3 for my lasts. I'm running out of space. And notice I just realized that I made an egregious multiplication mistake above. What did I do? I accidentally wrote 3 times 60, which was my inside number, and that's not what I meant. I really meant 3 times 20. So let me fix that. And so when I fix that, these shouldn't be 180. Those should be plus 60, plus 60. Because the total number of squares should be 400 plus 60 plus 60 plus 9. So that's 400, 460, 520, 529. And now that looks a lot closer to what I thought the answer should be. I'll share that, my gut was like, man, that number seems pretty high. And remember, we can actually check this another way too. So that's one way we can check this strategy. But let's look at another way. 23 times 23 is 23 times 20 plus 3, not 30, plus 3. 23 times 20 is 460, plus 23 times 3 is 69. And 460 plus 69 is 529. All right, so now that I've found that same answer two different ways, I feel fairly confident that we're accurate. And just for completion, we'll go ahead and calculate it one more time. 400 plus 60 plus 60 plus 9, that is in fact 529. So, be careful as you're going along. We all make mistakes. Did we answer the question? So, what's wrong with Kylie's idea? The only issue is she missed some of these squares. She missed these two groups of 60 in her calculation. Now, Annie, it says, is working on the multiplication problem 19 times 21. So she says that 19 times 21 should equal 20 times 20 because 19 is 1 less than 20 and 21 is 1 more than 20. And right, that's a really great connection to try to make, but what happens when we do that? So if I look at this, it says that there are 20 rows and 21 dots. So Annie's trying to solve 19 times 21. What does that look like in the array? Well, that's going to be 19 of the rows and all 21 of the columns. So that's this portion in red. That's the 19 times 21. But she's supposing instead, or proposing, that we can solve 20 by 20. So what does that look like? So that's going to go all the way down 20 rows and 20 columns. And so this part in green is the 20 by 20. So what's common to both of these boxes, right? That's this inside part that has 19 rows and 20 columns, 19 by 20. So in the 19 by 21 case, we need to take the 19 times 20 and add to it these dots that are only in the red part. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right, so we're looking for 19 times 20 plus 19 more dots. But when I calculate this 20 by 20 case, I have that same 19 by 20 that's common to both, but then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 more dots. So what's the difference here, right? Both of them have that 19 by 20 part in common, but our actual answer, which is up here, the 19 by 20, only has a plus 19, whereas the 20 by 20 case has this plus 20. So it turns out that Annie will add one more dot than we want. And so that's why drawing our picture is always helpful in solving these sorts of problems. And then here we have our last one. Mary's working on 19 times 21. Well, she says that 19 times 21 is 21 less than 20 times 21. And 20 times 21 is 20 more than 20 times 20, which she knows is 400. So Mary thinks this ought to help her calculate 19 times 21, but she can't quite figure it out. Right, so I want 19 times 21. And so she thinks of it as 20 minus 1 times 21. Or she thinks of it as 20 times 21 is 20 more than 20 times 20. So how do I connect that to this? So 19 is 20 minus 1 times 21 is 20 plus 1, right? So I'm very happy to see this line of reasoning, right? Because I have 19 times 21, 20 21s is 420 minus 21. And so I have 399. And so let's see if we can make the second one work. So I have 400 plus 20 minus 20 minus 1. So 400 plus 20, 420 minus 20, 400 minus 1 is 399. So that's what we needed to do to make her second line of reasoning work.